Hello everyone. So in this video we will revise a few RC circuits. So these circuits have been explained in the channel before as well, but the video was in Hindi. So I thought I should make the video in English as well. Okay. So you can read the equation. The capacitor C1 is charged to plus V volt. Already charged to plus V volt, and at t equals to 0 the switch is closed in all the circuits. Now you have to tell the waveforms, voltage waveform at C1 and C2. For t greater than 0 and for t less than 0 you have to draw the waveform. So first we will solve circuit A. Okay, so you see here, see whatever the concepts we have learned in the previous videos, the same concept will be used here only. Okay, see, I have told you how to see the circuit. So at t equals to 0, the capacitor, what does the capacitor C1 says? As per the capacitor C1, if it is holding its charge, so at as per the capacitor C1 the value of V out should be plus V. Okay, and as per the capacitor C2 the V out value should be 0. So what is happening here, the basic rules are being broken. So whenever there is condition of invalid KCL or KVL, the capacitor doesn't follow its basic property and change its voltage immediately. So how it will change its voltage? So what is the initial charge in on capacitor C1? It's C1 V. And what will be the steady state charge? So at steady state, just as you close the switch, it will reach steady state because there is no resistor, so it will take zero time to reach the steady state. So at steady state, both of them will be having a common voltage. So let us assume the voltage is VC. So that will be the common voltage, and so for calculating the total charge we will write VC into C1 plus C2. So this will be the total charge. So what will be the common voltage? So it would be C1V upon C1 plus C2. If the capacitor C2 was having V2 charge and C1 was having V1 charge, so what would be the common voltage? C1 V1 plus C2 V2 upon C1 plus C2. So many of you must have remembered this formula. Okay, so now you can easily draw the waveform. Okay, so for VC1 it will go from plus V then to C1 V. So this is plus V, then it is C1 V upon C1 plus C2. So this is for VC1, and for VC2 it will go from 0 to immediately C1 V upon C1 plus C2. That is for VC2. Okay, also you can see at t equals to 0, how can you draw the circuit? The circuit will be something like this. This capacitor can be replaced by a battery of voltage V, and this will be replaced by short circuited. Okay, so again there is infinite amount of current flowing through the circuit. So whenever there is infinite amount of current flowing through the circuit, the capacitor doesn't follow its basic property of charge conservation. It will immediately change its voltage. So that's how it changes its voltage. Okay, now moving on to the second circuit. Okay, so here what do you see? At t equals to 0 you try to draw the circuit at t equals to 0. V voltage, okay, a resistor R, and this will be shorted. Okay, we know. Now you tell me at t equals to 0 is there infinite amount of current? No, at t equals to 0 the value of current is V by R only. And now because of this V by R current, the capacitor C2 will start charging. So at t equals to 0 the V naught is 0 only at t equals to 0. Why? Because there is no basic rules are being broken, and there is no infinite amount of current. So the value of V naught is 0 only at t equals to 0. Now what is happening? Because of the V by R current, the capacitor starts charging. Now let us assume the V value is 5. Now after some time the capacitor C2 is charged to 1 volt. Now what will be the current? At t equals to 0, what was the current? 5 by R. After some time 4 by R. Then again it charges. The current will be 3 by R. To 2 volts. Then let us assume it is charges to 3 volts, and this will be 2. So this can't happen. So let us assume it is charged to 2.3 volt and it is charged to 2.7 volts. So what will be the current? The current will be 0.4 by R. So there will be one time when both of them will be having common voltage, and at that time there will be no current flowing through this resistor. When both of them will be having a common voltage, there will be no current flowing through this resistor, and that will be the steady state only. Now for finding the common voltage, what you do? Vc equals to C1V upon C1 plus C2. Okay, so basically this capacitor C1 is going from plus V volts to C1V upon C1 plus C2, and this capacitor is going from 0 to C1V upon C1 plus C2. So this one is charging and this one is discharging. So this one discharges to C1V upon C1 plus C2, and this one charges to C1V upon C1 plus C2. Now you can also see that at steady state there will be no current flowing through this resistor. So this resistor can simply be replaced by a short circuit, because there is no current, so there is no voltage drop across it. So this will be only a short circuit at steady state. So it will again reduce to the first circuit we just discussed. It will reduce to this circuit only. So that's how we find the value C1V upon C1 plus A2. You can see by one more way. I have told you whenever there is DC voltage applied. So at steady state, what is omega value? At steady state, omega equals to 0. I have told you in the previous videos. So at steady state, omega equals to 0. So because of zero frequency, the impedance provided by the capacitance will be very high, and in series, what is dominant? The higher impedance. So this can be neglected. So in series, so you can simply replace the RC circuit by only capacitor C. Okay, so these are some methods you can see. Okay, so but basically in the interview, what will you say? In the interview, you will say at t equals to 0, there is V by R current. So this current starts charging the capacitor C2, and the capacitor charges until both of them will be having an equal voltage. So what is the equal voltage? The equal voltage is C1V upon C1 plus C2. Now how did you get it? You get it by this, and then you can simply plot the waveform. Okay, so for VC1 it is going from plus V, and not like this, not immediately. It goes from plus V like this, plus V to C1V upon C1 plus C2. And for VC2, it goes from 0 to C1V upon C1 plus C2. So there is no case of infinite amount of current in this circuit. Okay, now let us move on to third circuit. So okay, so first you should try drawing the waveform by your own. Now let me explain it. So in this circuit at t equals to 0, what do you see? This capacitor C2 wants the V out value to be 0, and this capacitor C1 wants the V out value to be V. Again there is some invalid gases. So again there will be instant change in the capacitor voltage, and also you can see at t equals to 0, this will be reduced to a battery V. This is a resistor R, and this will completely be shorted. So at t equals to 0, again there is infinite amount of current, and whenever there is infinite amount of current, the capacitor doesn't follow its basic property. It immediately changes the voltage across it. So what is the voltage? That will be a common voltage, and the common voltage is C1V upon C1 plus C2. And so this is happening at t equals to 0 only. So at t equals to 0, we are having VC1 is C1V upon C1 plus C2, t equals to 0 plus actually, and VC2 equals to C1V upon C1 plus C2. Now what happens? Now this is a certain amount of voltage. Let us call it V1. Okay, V1. So now we are having V1 voltage here. Now because of this V1 voltage, we are having V1 by R current, and this current is coming from here and from here. Now the capacitor are charged in this direction, and the current is flowing out of the capacitor. So the capacitor are starting. So the capacitor have started to discharge. Now because of the discharge, the V1 will go down. Now let us assume V1 was 5, then it will go down to 4, then current will be 4 by R, again discharging, and it will go down, it will go down, it will go down until we are having zero current in the circuit. And whenever there is zero current, there will be no charge on the capacitor, and there will be no current flowing through, no current in the capacitor. So basically VC1 is going from C1V upon C1 plus C2 to 0 volt, and it is going from C1V upon C1 plus C2 to 0 volts. So let me draw this waveform. So for VC1, okay, so in VC1 from plus V to immediately C1V upon C1 plus C2 and then die out to 0. And for VC2 from 0 to immediately C1V upon C1 plus C2 and then die out. So these three are very important example. No register involved, series register involved, and parallel register involved. So in any interview, you will surely face these circuits, surely. And most of the cases, they will give C1 equals to C2 equals to C. In most of the cases, so the common voltage will be V by 2 only. So that you know already. So these three are important. So let me revise it once again. So in this one, what do you see? At immediately it will change the voltage. The common voltage is C1V upon C1 plus C2. Now in this one you see there is no case of infinite amount of current, so the V out is initially 0, and because of the current V by R, the capacitor starts charging, and it charges until both of the capacitor are having equal voltage. So the equal voltage is C1V upon C1 plus C2, and in this circuit you see there is infinite amount of current flowing through the circuit at t equals to 0 only. So because of that, the capacitor will change its value immediately. So what will be the immediate voltage? C1V upon C1 plus C2. Then what do you see? Because of this resistor, all the voltage, all the charge that C1 and C2 has stored is getting discharged through this resistor. So it discharges and discharges until the voltage across both of the resistor, both of the capacitor goes to 0. So these are the waveforms. This one for second, and okay, this is VC2, and this one for third. So these are very important examples. So most of the students don't know how to realize it intuitively. You can solve it by Laplace, that is very easy, but in the interview you have to tell it intuitively. So I remember I was exactly the same circuit, this one. Okay, okay, and then you may put the comment in the comment section if you have any review, and if you appreciate it, then you can like it. Okay, and I guess I have improved my English this time. Okay, thank you.